Now we are going to use a Tektronix TDS 2002B 2-channel oscilloscope and an Instec GFG 8210 function generator. I'm going to connect a BNC to clips connector to the 50 ohm output of the function generator. Usually we won't want to use the TTL CMOS output. That's always a 5 volt peak-to-peak signal with a DC offset, and it's always a square wave. I'm going to connect an oscilloscope probe to channel 1 of the oscilloscope. Do not use a BNC to clips connector for the oscilloscope in place of the probe. The probe is designed for this purpose. And never use an oscilloscope probe to try to connect a function generator. It just won't work. To measure the signal coming out of the function generator, I can connect together the earth grounds of the oscilloscope and the function generator, and I will connect the probe to the red lead coming from the function generator. The function generator is set to a sine wave of about 1.19 kilohertz, and I can see that sine wave displayed on the oscilloscope screen. If I want to change that frequency, I can do that with the frequency knob right here. I can also change the frequency by a lot, going to a different scale, such as 10 kilohertz. And I have a number of ranges all the way up to 10 megahertz. If I want to put a DC offset on that signal, I pull out the offset knob, and then I can adjust the DC offset, which uniformly shifts the signal up or down on the voltage axis. To disable the offset, I just push that in. The function generator has two 20 dB attenuators. A 20 dB attenuator reduces the amplitude of the signal to 1/10 of the original amplitude. One of them is here. It's this button. If I press that in, it reduces the amplitude to 1/10 of the original amplitude. Instead of 1 volt amplitude, now we have 0.1 volt amplitude. If I pull out the amplitude knob, that gives me another 20 dB attenuation. Now I have 1/100th of a volt amplitude, and it's too small to see on this scale. If I adjust the volts per division on the oscilloscope, I will again be able to see the sinusoidal signal. Now, if I want to change the seconds per division for the horizontal scale on the oscilloscope, I do that with this knob, and that's for both channel 1 and channel 2. I haven't changed the waveform, but I've changed the way it displays on the screen. Now I have 500 microseconds per division. This is at 1 millisecond per division, and so on. Let's say I want to measure the peak-to-peak amplitude of this signal. I can use the measure function. I want to measure something to do with channel 1. So I set my source to channel 1. The type of measurement I want to do is the peak-to-peak. And the value is 224 millivolts. If I head back, that channel 1 peak-to-peak value remains displayed on the oscilloscope. Now, let's say I want to measure a difference between 2 points in time on the oscilloscope. For this, I can use a cursor. And I'm using channel 1. My type of cursor is time. My source is channel 1. And I can use this knob to adjust the position of that cursor. I positioned it here, at this peak on the waveform. Now I can set a second cursor. This is also going to be time and also channel 1. I can adjust the position of that with the knob when it's selected. And so now I can measure the difference in time between these two peaks of the waveform. The delta t is 1.68 milliseconds, and that's the expected period for a signal that has a frequency of 603 Hertz. Well, that's a brief introduction. You can see that these two instruments have a lot of other features you can use.